I'm gonna start a new series of videos. This time, those videos are gonna be based on the Dell Enterprise SONiC networking operating system. SONiC stands for Software for Open Networking in the Cloud, and it was initially started by Microsoft and the Open Compute Project. And one of the reasons why I'm gonna study this operating system is because this operating system is supported by a lot of big vendors. Just to mention a few, according to this wiki, let's read a little bit. It says the SONiC community includes cloud providers such as Microsoft Azure as the biggest one, service providers, silicon and component suppliers. Keep in mind that a lot of the networking switches that the tier 1 vendors are selling are basically mostly made with Broadcom chipsets, just to give you an idea. And of course other switches are using Cisco ASICs or from Nvidia, Mellanox, but there is a huge part of the white box networking switches that are using Broadcom chipsets, for example. So this is big, this is huge, as well as networking hardware OEMs like Dell and ODMs. So basically it has more than 850 members that are enhancing the capabilities of this networking operating system. Some of these companies that are contributing to SONiC include the Alibaba Group, Avis Networks, Celestica, Arista Networks, Broadcom, Dell, Cisco Systems, Comcast, Juniper, Nokia, Nvidia, Mellanox, like I was mentioning a few seconds ago, and VMware, which it has a big chunk of the virtualized market. SONiC is used in Microsoft Azure networking services, just to give you an idea how important this operating system is. So the idea of going with a vendor, in this case Dell, is that Dell is taking this SONiC operating system and is enhancing, and it has engineers ready to fix any issues that might arise without having to wait for the open community to come up with a patch or solution. So having said that, introduction. This document is intended for technical professionals whom want to learn about enterprise SONiC distribution by Dell Technologies network operating system. This virtual lab environment runs the enterprise SONiC operating system. As this is a virtual lab, it simulates physical hardware, therefore the performance may be slower than labs that have physical infrastructure. That's understood. We are working on a GNS3 emulator, and I'm connecting from my home all the way to a Dell lab that has servers actually running this virtual environment. So that's what they're saying here. But I can also run it on my personal workstation and my GNS3 software. I can do that as well. Software for the open networking in the cloud, SONiC. And I might be redundant a little bit here, but I think it's worth it. Repetition is the best teacher. SONiC is an open source network operating system based on Debian Linux. Just like Dell OS X is based on Debian Linux and run on switches from multiple vendors, in this case, this SONiC can. SONiC offers a full feature set that has been in use in data centers of some of the largest cloud service providers, such as the Microsoft Azure Cloud. So basically what they're saying here is that this SONiC operating system it has been proven, it has been hardened, and it continues to be enhanced by the community. Then it says here, since it is open source, SONiC helps users leverage the collective strength and take advantage of the vast ecosystem and a community. So that's what I was referring to from this Wikipedia article or document or wiki. Enterprise SONiC distribution by Dell Technologies. Let's see what is important here. Well, let's read it. Enterprise SONiC distribution by Dell Technologies, also known as Enterprise SONiC, is an enhancement to the SONiC community version. The Enterprise SONiC is based on the open source SONiC OS, which includes feature enhancements, hardening, and support targeted for the demanding data center. And check it out, leaf and spine fabrics, while maintaining the open source spirit. Enterprise SONiC provides the benefits of partnering with the SONiC community on a highly scalable open source network operating system. SONiC is based on a modern containerized architecture that accelerates innovation and evolution. So this is another reason why this operating system was developed, because a lot of the cloud providers and service providers need to run additional networking services, and by using this containerized architecture, SONiC is a more advanced operating system than traditional Cisco proprietary or Dell proprietary operating systems. I believe that each different operating system bring benefits, right, to most customers. Like, for example, you can buy a Cisco iOS, Nexus switch, or a Dell power switch running operating system 10, and that's gonna serve the majority of customers, right? To build layer 2, layer 3 networks, using EVPN, BGP, being able to do VXLAN, overlay tunnels, and being able to virtualize a set of hardware. But this SONiC operating system was built from the ground up to support all these hyperscalers. And even though this this operating system is very capable for these hyperscalers and service providers, all this richness of feature sets are of great value for enterprises of any size. SONiC is based on a modern containerized architecture. That's what I read. The customer will also benefit from Dell Technologies enhancements, including hardening and validation of enterprise-ready data center use cases and support on selected Dell EMC power switch family of industry-leading open networking switches. And the reason why they're saying this is because these Dell switches can run the Dell operating system 10 as well. Let's see what else. It says Dell Technologies has released a virtual appliance version of the Enterprise SONiC network operating system for the Dell EMC Power Switch S5248F. Customers It's meant for customers and other interested people that can use this virtual machine to simulate experiment with, and test various network topologies. It enables the provisioning of a robust and proven network operating system across production and development platforms with a uniform enterprise SONiC distribution as a single image consistency. The Enterprise vSONiC appliance is used to test various network configurations and integration in a simulated environment. So that's the whole purpose of this lab. So let's go ahead and do this architecture. Introduction to the Enterprise SONiC operating system. Basic. This module introduces the Enterprise SONiC operating system and how to configure the interfaces and IP addresses. Very basic. Enterprise SONiC distribution operating system. Getting started. The Enterprise SONiC distribution by Dell Technologies operating system enables disaggregation of the operating system from the underlying hardware. Okay, so that's why in a Dell Power Switch you can use the Dell Operating System 10 or Dell Enterprise SONiC. You will gain first-hand experience with the configuration of VLANs, assignment of IP addresses, and the basic Enterprise SONiC operating system commands using the management framework command line interface. So what I mean by this sentence, in the beginning, the SONiC CLI or the SONiC way to program the switch was very different, and it was not anywhere close to the industry standard CLI or the very Cisco iOS feel of doing CLI, which is very user-friendly. So just like with Dell OS 10, in which you can have a CLI very similar to Cisco, very similar. A lot of vendors try to follow, the industry leader, right? And that way, it's easier for people with Cisco certifications to work on Dell OS 10. Super easy for them to configure Dell switches running OS 10. And this is the same idea with this Dell Enterprise SONiC. The idea is for people that are trained or Cisco trained engineers or administrators to be able to quickly start configuring these switches using a CLI that they are familiar with. So that's this management framework command line interface that we're going to explore in this lab. Introduction to Enterprise SONiC. This module contains the following lessons. Introduction to the Enterprise SONiC operating system module overview. Lesson 1, GNS3. Lesson 2, overview of the Enterprise SONiC operating system. Lesson 3, configuration basics, and a conclusion. So let's move on. Introduction to the Enterprise SONiC operating system model overview. Enterprise SONiC distribution by Dell Technologies, also known as Enterprise SONiC, is based on the open source SONiC OS, which adds feature enhancements, hardening, and support targeted for the demanding data center leaf and spine fabrics while maintaining the open source spirit. Enterprise SONiC by Dell offers a full suite of network functionality such as MC lag, multi-chassis lag. If you watch my OS 10 videos, I talk about that technology. In the Cisco world, it's called VPC, Virtual Port Channels. The support of VRRP, the support of spanning tree, in this case PVST, the support of VXLAN to create overlay networks with BGP, and it can support large data center environments. Benefits and some benefit summary. Enterprise SONiC offers compatible network capabilities in an open source environment that uses multiple containerized components. Flow containers can be restarted independently with almost no system downtime. You can add new third-party, proprietary, or open source components to tailor enterprise SONiCs to your needs. The community participation accelerates software development and continually offers new features. So this is key. Like I mentioned on that wiki page, it's just there is a lot of big players behind this effort, and this operating system is already in prime time. It's already working. This lab focuses on the configuration of the Enterprise SONiC operating system using the management framework CLI. In this module you will get a quick introduction to GNS3, the overview of Enterprise SONiC 3.1.1, the configuration of VLANs, configuration of interface IP addresses, and the configuration of port channels. So lesson 1, GNS3. The GNS3 software emulates the Dell Enterprise SONiC operating system that runs on the Dell EMC power switch S5248. This S5248F is a switch that has 48 ports of 1, 10, 25 gigs, and but on this virtual environment only 10 ports are enabled. Port 0 is for the out-of-band management port, and from port 1 to port 9 are the only available ports for this appliance. So network engineers use GNS3 to emulate, configure, test, and troubleshoot virtual and real networks. That is well known. GNS3 enables you to run a small topology that consists of only a few devices on your laptop to those that have many devices that are hosted on multiple servers or even hosted in the cloud. Like I'm doing right now, I'm connecting to the Dell lab, so I'm actually connecting to their cloud. And then GNS3 is an open source and free software. So right now I'm connecting the client. Actually, I'm connecting from my home to this Dell lab, and the Dell lab has the GNS3 client and the GNS3 virtual machine server. The GNS3 server virtual machine, right? Another setup is like the one I have at home, in which I have my Dell Precision Workstation T9810 with a dual 6-core Xeon processors, 32 gigs of RAM, and plenty of disk space. That's where I run my client GNS3 and my server VM GNS3, and there is another option that you can have your laptop or desktop running the client GNS3, and then you can have a separate server that is connected to a local network in your home, for example, or your lab, and then in that server with multiple processors, multiple cores, and more RAM, then you can create larger fabrics to test larger, more complex topologies. But for most people, a workstation and even a workstation and a little server will help to test things and not only to learn but also to validate and plan and test several configurations. Open the GNS3 application. I already did. This is the topology. It's right there. I already talked about that. It says here only the management interface Ethernet 0 and the first 9 front-end interfaces Ethernet 1 through Ethernet 9 are available for use in GNS3. So that's what I was saying. Note, Linux servers will be used as host interfaces, and we have host 1-40 represent host 1 in VLAN 40. To identify the connected ports between the switches, hover the cursor over the green dot on the link. So let's do that. And then it says there, link from host 1-40 port ENS0 on the host to switch 1 Ethernet 1.1. Okay, so that's good. So let's continue. It says to activate the consoles, right click the device icon and select console. Yeah, I already did that. I open these PuTTY sessions for each of the switches and for each of the hosts. So let's continue. Overview of the Enterprise SONiC operating system. That's lesson number 2. Overview. So let's take a look. Switch 1 login. This lesson provides an overview of the Enterprise SONiC operating system that is loaded on all of the switches. Double click on the router icons. I already changed those icons. To open the terminal emulator, to log in to the switches, use the following credentials: admin. Then it says here, note, the default SONiC login password is admin, and look at this. For simplicity, all devices logins have been changed to admin just to make it easy for the lab. So let's go ahead and go to switch number 1 and see how it looks like. The CLI, so that's switch number 1. So let's go ahead and I already changed the name to switch 1. So let's do admin, and the first thing you see, the first line, it says Debian GNU/Linux 9 switch 1, and once I log in, the first thing that you see is a banner that says you are on SONiC, which stands for Software for Open Networking in the Cloud, and some disclaimers right there. And then it's showing you here the admin, that is the user that is logged in, which is me, the admin, and it's showing you the symbol and then the name of this switch, which is switch 1. So that's interesting. And then you have this number sign that is very Linux-like. So let's continue. So disable zero touch provisioning. I already did that. Whenever I first started this lab early in the morning, I disabled the zero touch provisioning because if you don't do that, the system is gonna try to look for if there is a provisioning server, so that way it can get an image loaded into the switch, or to get a configuration loaded into the switch. So in this case, I just ran this command. It's a Linux command, which is a sudo, I think super user, ZTP, which is zero touch provisioning, disable space, and say Y as yes. And once you do that, then that's gonna disable the zero touch provisioning, and once it's disabled, then you can run the show command, show ZTP command, and then you're gonna see that I'm on the lower right of the screen. You're gonna see CTP admin mode false because I disabled it, CTP service inactive, and the ZTP status not started because it's disabled. Validate that the system is ready. So let's do that. Let's do show status, system status, system status, and then it's saying that the system is ready to rock and roll. All right, so let's go to the next one. Linux shell. The legacy SONiC CLI uses a prompt with the format username at hostname. The default username is admin and the default hostname is SONiC. That is the default. I already changed it to switch 1. The user is greeted with the Linux shell when accessing the enterprise SONiC network operating system. The list of Linux shell commands available is invoked by typing help. So let's type help and see what happens. Help. I need somebody. Help. Alright. So then you're gonna have all the different commands available like cd command, compgen, echo commands, exec. So there is a bunch of commands that are used on this Linux shell. So let's keep on going. Legacy SONiC CLI. So I think this is worth reading. The legacy SONiC CLI is built on the implementation of Python click library. The CLI components provided, the CLI component provides the administrators with a customizable approach to creating command line tools to make our life easier. Note, the legacy SONiC CLI is only covered to introduce the concept. All the exercises will be executed, and this is a good news for us, in the management framework CLI. I'm glad because I'm not a Linux expert at all. So that is something I'm gonna have to take a crash course, maybe a 30-day introduction to Linux. I just know very basic commands to navigate, but that's about it. But MF CLI is gonna be very Cisco-like, very Dell OS 10 like, very easy for people with Cisco certs. Then you have the show commands. So let's go ahead and do a show command. Let's do show and then question mark. And this looks a lot more than, and this looks more like Cisco-like, Dell-like, Brocade-like, Ruckus in this case, way of being able to just do question mark and get all the options for that particular in this case Linux shell, right? So let's see. Let's go to the next one. View configuration. Let's take a look at this view configuration. This scared me a little bit because I'm not a programmer. so let's take a look. It says here to run show configuration, show running configuration all. So let's do that. Let's go back here to switch 1 and let's do show, let's see here, running, tab to finish that all, and then this pipe more. Okay, so let's hit and then you're gonna see on the left all these yeah, intimidating stuff, but if we pay attention, it's just saying that this is the OOB ARP, this is information for the DHCP client, some information about to view the running configuration and JSON format, type the command I just did. Let me go to the ports. I think I'm gonna be able to make some sense. There you go. I can make some sense of this. So if I see the management interface, it's showing me that Ethernet 0, which is the out-of-band management interface, has an IP address of 192.168.153.3 32/24, and the gateway address is 192.168.153.254. So that makes sense. And I'm looking at the management port over here, and the MTU is set to 1500 bytes, and the speed is 1000. So yeah, this is look more familiar now. This looks familiar to me. Then the next topic is going to be the management framework CLI. The management framework CLI is being developed to provide an industry standard CLI format. Many commands are available in MF-CLI at this time, and most use cases might be configured using this MF CLI, which they could have used a better name here. If I were writing this, I would say management framework, the whole thing, right? Not the MF CLI, but this MF CLI is the one we want to use to make our life easier. besides automating, right? However, there are some commands that might need to be executed in the Linux shell, and that's understandable. If you had to use any of those functions that you need, that the most customer won't need, then there is some guides in how to execute those commands in a Linux shell. So on switch 1, enter the management framework CLI by typing SONiC-CLI. If the sudo shell was entered, you must exit before entering MF CLI. All right, so let's go ahead and exit. Let's do admin, and let's do SONiC CLI. And just pay attention how we have this number sign on this Linux shell. So if I type SONiC CLI and hit enter, then it took me to switch 1, and that's the name I changed already. Okay, so let's continue. Yeah, before it was admin add SONiC. Erase the configuration. Another thing I did, I deleted the configuration on this switch. It says to erase the configuration file except for the management interface configuration, which is important to keep it. Type write erase and then reboot. That's what I did. I did type write erase and then I type reboot, like just like it's here, right here. Okay, so let's continue. Interface configuration commands, interface naming support, SONiC native mode, and Dell standard mode. Naming conventions. In native mode, interfaces are named Ethernet 0 through Ethernet N. Okay, and now I understand. In a standard mode, the interfaces correspond to the switch from panel numbering, which is Ethernet 1 through Ethernet 1N. So that makes sense why when I was looking at the Linux shell, that JSON file, that's why it was saying Ethernet 0, but then below it had a different number. When I was looking to Ethernet 1, yeah, so that threw me off. But in this case, we're going to be using the standard mode. So to do the standard mode, there is a command that has to be configured, which is configure terminal. Then interface naming standard, I did that already. And to exit that mode configuration, config terminal, and then write memory to save the running configuration to the startup configuration. I have done that already. Then I exited and type SONiC CLI, and that's why I'm able to see this switch right here with a new config file. Hostname, I did the usual, configure terminal, hostname switch 1, and then save the running configuration to the startup config. It says here, after changing the hostname, you must exit and re-enter the the management framework CLI to activate. Okay, done. Management interface. The Ethernet 0 interface denotes the out-of-band management interface. It is also identified as the interface management 0. This management interface is set to obtain an IP address using the ACP, and it can be changed to a static value, and that's what I did. But let's take a look. Let's do config terminal and then go into interface, and then you can do question mark, and that's the options. So let's do management, tab to finish the word 0, which is the out-of-band management. Now I am in that interface, out-of-band management 0. So let's see if the show configuration works on this one. Show configuration, yeah, it will. So if I type show configuration, that's nice, because now it tells me that the way it's configured. In this case, we have the MTU of 1500 bytes. We have auto negotiation on. The speed is 1000, which is 1 gigabit per second. And the IP address, I already set that in the morning to 192.168.153.32/24. And then one thing I noticed that is not on the Cisco or the Dell's OS 10, for example. I might be mistaken on the Cisco, but it's nice to see that GW address, which is the gateway address, and I think that was interesting. Is saying that the gateway address is 192.168.153.254, and then you write memory to save that configuration. It says the out-of-band management interface Ethernet 0 will not be used on this lab. That's fine. So let's take a look at the front panel interfaces. So let's do show interfaces status. So let's exit this. Let's go ahead, and I need to go to the exec mode. So let me exit this as well. I should have do end to go all the way to exec mode. So in this case, I'm gonna do show interfaces status. But normally in a switch, it's gonna look like this. So basically, you have on the left, on the right, it says Ethernet 1.1 down. All the ports are down. It tells me here that do not worry about operator and speed and all this over here, because it's an emulator. So we just pay attention to this for now. And this is just to show you how it looks like in a real switch. It says here the GNS3 SONiC appliances that are used in the lab are configured with only 10 active interfaces per appliance. The first interface is Ethernet 0, which is the out-of-band management interface. The front panel interfaces available are Ethernet 1.1 through Ethernet 1.9. Then it just shows you an option of how to do a dynamic port breakout, but I'm not gonna get to that. But it says here, unfortunately, we cannot demonstrate this with GNS3 for many reasons. It doesn't have an NPU network processing unit, so there is a few things we cannot do on this lab, but the majority of the commands we can. It says show version. Let's see the show version. Control C. Let's do show version, and then it's showing the version. Let's check over here. It says version 3.1.1 generic. The product is Enterprise SONiC distribution by Dell Technologies. It shows also the kernel and many other information pertaining to this SONiC version. This concludes lesson 2. Please continue to the next lesson. Okay, so it's a role-based access control, RBAC, role-based access control. So this provides control for access and authorization. Enterprise SONiC supports two predefined roles, the admin and the operator. So the admin provides full access to all commands in the system, exclusive access to commands that manipulate the file system, and access to the system shell. A system administrator can create user IDs and user roles. Operator provides access to the exec mode to view the current configuration with limited access. A network operator cannot modify any configuration settings on a switch, only allowed SSH access to the management framework CLI and no Linux access. So that those are some of the two roles. And it says here configure terminal, and then you just go, well, let's do it because I haven't done that. So let's do Control C, and let's go ahead. Let me see if I can make this better. Yeah, let's see. Let's check something out. Oh yeah, this is a whole lot better. I just maximize the screen. That's fine. All right, so let's get rid of this. Let's do Control C, and let's do show version. Yep. Okay. Control C. Now let's do this configure terminal, and I'm gonna drag these commands. Username, user1, password 1, role administrator, and username user2 with the password 2, role operator. So let's do that. Nice. Let's move to the next screen. It says show running configuration. To view the current configuration type, show running. So show running configuration question mark, and it gives us all the options. Let's continue. Lesson 3, configuration basics. So it says here, Enterprise SONiC operating system has all the interfaces in layer 3 mode by default. Okay. To configure an interface for layer 2, first assign the VLAN interface. Okay. Then assign the interfaces to the VLAN ID. Optionally, an IP address can be assigned to the VLAN. So here is the basic topology. It shows here that this VLAN 40 is going to have an IP address of 192.168.40.253/24, and then in switch 2 you have that VLAN 40 with 192.168.40.252/24, and then the host 1 is going to have the address of 192.168.40.101, and host 2 is going to have the IP address of 192.168.40.102, and it's going to be the 192.168.40 network. Let's continue. Configure switch 1. So let's go ahead to switch 1 and Control C, and let's go ahead and do select console, open switch 1, admin, enter the management framework shell. I am in it already, so let's continue. I'm gonna, just for timing, I'm gonna go ahead and drop all these commands. And I'll talk about them. So what is happening? Let me go here to the left of the screen. Let's go ahead and, so after going into config terminal, we're gonna create interface VLAN 40, and we're gonna give an IP address. In this case is 192.168.40.253/24. Then we exit, and then we're gonna go to interface Ethernet 1.1, which is the first port, and we're gonna describe description host because Ethernet 1 is going to host 1, and then we're gonna make it part of VLAN 40, switch port access VLAN 40, not shutdown and exit. So that's what it's doing on this set of commands. Let's move to the next one. It says configure port channel. So let's drag all this and I'll explain. Okay, while that's happening, so it says here, the following options must be selected when creating the port channel. If changes need to be made at a later date, the port channel will need to be deleted and re-entered. So just make sure that you understand what type of port channel you want to use. Fallback, LACP fallback is one option. Fast rate, LACP fast rate interval. The minimum links for port channel to stay up. The mode, in this case, a port channel mode active or on. In this case, let's say that mode on is a static link aggregation group. And it says here, now create a static port channel 100, and add as a tagged member of VLAN 40. So that's what we're doing on this particular set of commands. Then add Ethernet 1.5 and Ethernet 1.6 as members, then save the configuration. So let's go ahead and take a look at this new set of commands on this left screen. So it starts over here. It says interface port channel 100 mode on. So that's creating that port channel. We're gonna add a description, static lag to switch to, which makes sense. Switch port trunk allowed VLAN at 40. Interesting. Okay. Switch port trunk allow VLAN, and this command I never seen before is at 40. Okay, but that's fine. Let's see what else. If I see Ethernet, okay, and there is the configuration for interface Ethernet 1.5. The description is port channel 100 member, channel group 100, no shutdown and exit, and the port 1.6 is also a member of port channel 100, channel group 100, no shutdown and exit. So let's go ahead and do enter. So it took that command. So it says here, SONiC port channel will be configured as static in this lab to reduce the GNS3 CPU load. It says that if you want to create dynamic LACP port channels in hardware environment, set the mode to active. So let's go ahead and verify the VLAN. So let's go ahead and do show VLAN. And then it says here that we have VLAN 40 on this switch 1. It has a tag port channel 100, and then you have an access port part of this VLAN 40, which is Ethernet 1.1, that is going to host 1. So this is good. Let's go ahead and verify the port channel using these commands. Show port channel summary and show interface port channel. So let's go ahead and do one first. Let's do the show port channel summary. And then it shows that you have group 100, port channel 100 up, Ethernet, and it has the member ports 1.5 and 1.6. So that's good. Let's see what else. Yeah, P up in port channel, so that's good. There was have this P description right there. Okay, so let's see what else. Okay, let's do the other command. Then it's showing port channel 100 is up, line protocol is up, mode static, the description static lag to switch 2, line speed is 50 gigabit per second because you have 2 ports of 25 gig. The MTU maximum transfer unit is 9100 bytes, jumbo frames, and the members 1.5 and 1.6, so that makes sense. GNS3 objects do not show the true operational interface status. At this point, there is no active interfaces on switch 2. So that's what it says on this disclaimer. Configure switch 2. ZTP is already disabled. So let's go to switch 2. Let's go ahead and select switch 2. Let's do admin. Okay, so now let's go ahead and create the port channel 100 and blah blah blah. I already talked about this. It's the same similar steps that we did for switch 1. Okay, so let's go ahead and continue. It says show port channel summary. So let's take a look at port channel summary. Okay, so let's make this bigger. Let's go ahead. Okay, maximize. All right, so let's do. All right, port channel summary. Ethernet 5 and 6 have the P, the P papa denomination, which is P, which is a P up in port channel members. So that's good, checked. Let's do show interface port channel. And then it's giving us all this information I talked about on the first switch. Let's go ahead and view configurations. Let's do show running configuration interface. View configurations. To view the interface configurations, enter the following commands. So let's do the first one. Okay, it says show running configuration interface port channel, and it's showing the port channel 100 information there, so that's good. Let's do show running configuration interface Ethernet 1.1. Okay, I did that again. Okay, so that's good. So now let's show running configuration interface VLAN. Okay, I know why. Okay, so that's the information for VLAN 40. Let's see what else. The configuration can also be shown in any configuration level using the show configuration command. Okay, So in this case, I can go to Ethernet interface. I can go to interface Ethernet 1.1 and draw the show configuration, and I did that already. So let's continue. So let's go ahead and do ping network. So let's go to host 1. That's host 1, and let's go ahead and do admin, and let's go ahead and do, let's do this ping right here, which is to 192.168.40.253. Okay, it pinged. We got a reply. So let's check the second ping, which is gonna be to 192.168.40.252, and it's pinging. And let's do the next one, which is 192.168.40.102, which is gonna be host 2, and that worked. Okay, so it says monitoring the network while pinging host 2 from host 1, monitor packets on switch 2 Ethernet 1.1 using TCP dump. To run TCP dump on switch 2, first find the alternate name for Ethernet 1.1 with the show interface status command, then exit. Run the following commands on switch 2. So let's take a look here. In switch 2 it shows interface status. Alternate name. In this case, the alternate name for Ethernet 1.1 is Ethernet 0. Interesting. Okay. Okay, so let's go ahead and exit. Okay, so now what we need to do on switch 2 is to run this sudo TCP dump -1 sudo TCP dump -i Ethernet 0 -v as Victor. I think this command needs to be done. Oh, I need to exit switch 2. I need to exit the management framework CLI, and I need to go back to the Linux shell, and now I can run this sudo command TCP dump. So let's go ahead and drag this. Okay, let's see what else here. Okay, so Linux will refer to the interfaces as alternate. Okay, Wireshark may be used to monitor traffic between devices. This is done by hovering over the link and right click, then start capture and press OK. So let's try that. Let's go to host 1. It says right click, and then it says start capture, and then OK. So what else is next? Let me see if I can go back here, host 1, and do a ping. Okay, so I went to host 1, I did a ping request, and then you got the ping reply. Okay, so that works. So if I go back to the GNS3, so I'm pinging from 1 to 2, and this is the link that I'm monitoring, which is the link from host 1 to switch 1. So let's take a look at the Wireshark, and yeah, okay, so that's good. To stop Wireshark, hover over the connection and click Stop Capture. So let's go back to GNS3. Stop capture. Okay, that's good. So yeah, it went dark here. Stop capturing packets is already stopped. Okay, so that's good. What else? It's 1:37 in the morning. Wow. Type Control C to stop the TCP dump in host and host 1 pings. So let me go to switch 2 and do Control C. Good. And this concludes lesson 3. It says, congratulations, you have completed the lab. Introduce you to the legacy SONiC CLI. Conclusion, congratulations, you have completed the lab. This lab introduced you to the legacy SONiC CLI and the enterprise SONiC management framework CLI from Dell, and provided you with the steps to show system information, configure a VLAN, add tag and untag members to a VLAN, assign an IP address to the interfaces, create port channels, add members to the port channels, run validation commands. And there is 3 more labs that I'm planning to do. One of them is going to be building a layer 3 fabric with BGP. The second one is going to be building a layer 2 VXLAN BGP EVPN fabric. And the third lab is going to be building a layer 3 VXLAN BGP EVPN fabric with some explanations, some whiteboards before doing the lab verification. And this is the conclusion. Thank you for participating in the Dell EMC hands-on lab. So that's great. I think I'm gonna stop here, and I have a lot of editing to do here. Have a great time.
Go, 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 go. You got a mind, but even that could change. You could flip the gray matter like some batter in your brain. That's why I say, fake it till you make it A. And if you